Okay, now the big hint in this question here is this little bit here. Treat Jeanette as having projectile motion. So we can attack this problem as a projectile motion question. We're asked to find Jeanette's takeoff speed, which is her velocity at takeoff, which is this velocity here. We're not going to be able to find that straight away. What we're going to have to find first is one of these components, and I think the vertical component will be the easiest. So what we'll find first is uv, the vertical component of her initial velocity. So what we know is she travels a distance of 1.9 meters, acceleration due to gravity is -10, final velocity is 0 at the top of her flight, and we need to find her initial velocity. So we can use v squared equals u squared plus 2ax, and that all works out to be uv equals 6.16 meters per second. So her vertical component of her initial velocity is 6.16. We need to use that now to find her initial velocity u. We know that u equals u sine 80, uv equals u sine 80, so we can put the value that we just calculated in for uv, and we solve for u, we find that u equals 6.26 meters per second. So that's a 3-mark question, it's pretty tricky. Moving on, how far horizontally has Jeanette travelled? So we're asked to find x, her horizontal displacement. Before we can do that, we need to find how long she spends in the air, her air time. So we can use her vertical component of initial velocity that we calculated in question 7, and acceleration velocity to find t. So v equals u plus at. T works out to be 1.23 seconds. That's her air time. So the t we calculated in the question was half that. So the air time, that's the total time she spent in the air, travelling up and travelling down again. So now we know her initial horizontal velocity, 6.26 cos 80. Her acceleration was 0, t was 1.23 seconds. So just like in the previous question on the previous page, I've set this one out here as a Zuvat question, but it's really just velocity times time. A is 0, so this term disappears. So velocity times time, horizontal velocity times time, gives this horizontal displacement 1.34 meters.